Today's math lesson is lesson 109, found on page 566 in your book. There are two really terms that we need to understand tonight. One is corresponding parts. If you look at page 166, it shows you two triangles, similar to the ones that I have up here on the board. Each triangle has three angles and three sides, and the angles and sides of triangle ABC correspond to the angles and sides of XYZ. Okay? What they mean by that is, I have A, B, C, and if you notice, this is a right triangle. I also have another right triangle over here, X, Y, Z. If I take this triangle and I rotate it 90 degrees, okay, rotate it 90 degrees, and then translate it or slide it, I've got them right here next to one another, okay? Now, I can do one more thing. I can flip it over, but before I do that, I want you to understand A will be laying on top of Z, C will be on top of Z, and point B will be on top of point Y. So when I reflect it, I have a triangle that looks like this. Okay? You can see at some point that this lies on top of that. Okay? Now I'm going to turn it back because I want to make a couple other points. We say that, okay, angle A corresponds to angle X, angle Z corresponds to angle C, and angle Y corresponds to angle B. Okay? Now, there are these sides. So we can match these up. We say BC, if you're looking at the bottom of the page, line segment BC corresponds to, what's the same length, okay? Be this one, YZ, okay? Or actually, I guess it should be BC corresponds to ZY. Sorry, gotta keep it straight. And then we'd have CA, line segment CA corresponds to line segment ZX, and then that would leave me with BA corresponds to YX. Okay? Those are corresponding parts. Okay? Now, take a look at the top of page. By the way, if two figures are congruent, the corresponding parts are congruent. Okay? So we know that the measures of all corresponding parts, whether they are angles or sides, in congruent figures are congruent. Okay, example number 1. Okay, I got two triangles. Right now they don't look very similar. We know, because I've shown you before, they are congruent. They are equal in size. Now, we're going to say have two measurements on one triangle. I think this is 3 inches, and this is 4 inches. Okay. We also know on the other one that this side is also 4 inches, and this side's 5 inches. And they ask us to come up with the perimeter of them both. This is 3 inches. This one was 4 inches. Didn't know what this one was. Okay? Now, because I can tell corresponding parts, this is 3 inches, that's 3 inches. If this is 4 inches, that's 4 inches, then guess what this one is? It's 5 inches. Okay? And 3 plus 5 is 8, and 4 is 12 inches for a perimeter, which is what you have there on example 1. Look at example 2. We have the term similar figures. The first sentence says figures that have the same shape but are not necessarily the same size are similar. Okay? There are 4 triangles. The first 2 look exactly the same shape and exactly the same size. Each of their sides is equal. Obviously, they are similar. They are similar because they're also congruent. Okay? Now look at triangle number 3. It, like the first 2, is a right triangle. Okay? And it looks very similar in shape. Okay? The only difference between 1, 2, and 3 are the length of their sides. So we say 1 and 2 are similar. We're saying 2 is similar to 3 and similar to 1. But then look at 4. 1, 2, and 3 have a right triangle. Is there a right triangle in triangle 4 at all? No. Actually, it's an equilateral triangle, which means each one of those angles is 60 degrees. It has 3 60-degree angles. Whereas triangles 1, 2, and 3 have at least 190. So we know they're not congruent. And because the angles are different, they're not even similar. So for figures to have the same shape, the measure of their angles must be the same. The only thing that can be different are the lengths of their sides. Okay? Turn to page 568. Look at example number 2. Okay, we have 2 triangles that are similar. Okay, they are both right triangles. We have one long side, we have one shorter side. If we rotate and then flip or reflect those 2 triangles, we get what they have down below, where we have a triangle ABC with C being a right angle. Okay? We know that the top angle is 30 degrees. The bottom angle is 60 degrees. Because they are similar in shape, we know that angle A obviously is 30 degrees and angle B will be 60 degrees as angle C is 90 degrees. So what have we learned? We've learned that corresponding angles of similar polygons are congruent, but sides are not necessarily congruent, but sides are proportional. Okay? The first fact there that the angles are congruent, it says the first fact means that even though the sides of the similar polygons might not have matching lengths, the angles do match. The second fact, number 2, means that similar figures are related by something called a scale factor. And we'll do an example of this here in a minute. Scale factor. Okay? Look look at example number 3. A scale factor is a number. It's not a letter, it's not a shape, it's a number. Multiplying the side length of a polygon by the scale factor gives the side length of the corresponding side of a similar polygon. Let's look at example number 3. We have two rectangles, A, B, C, D, and E, F, G, H. Okay, let me draw these. This is rectangle A, B, C, D. Okay, A, B, C, D. Okay, then we have a similar, okay, a similar rectangle, which I believe is E, F, G, and H. Okay, now look at the sides. 4 and 2, 2 and 1. We call this 4 centimeters, 2 centimeters. Down here, 2 centimeters, 1 centimeter. Okay? Now, because they're similar, we know the sides are proportional. Therefore, we set up a proportion. So, 2 is to 1 as 4 is to 2. Well, obviously, if we were to reduce this, this is the same as 2 over 1. So we say that the scale factor is 2 over 1, or just 2. Okay? Scale factor is 2. All right. Look at the top of the page. It says side AB to side EF is 2 to 1. Side BC to side FG is 4 over 2, which also equals 2 over 1. In all similar polygons, I'm at the top of page 589. In all similar polygons, the ratios of corresponding sides are equal. So the sides of the bigger one are 2 times the size of the little one. Okay? We say if they had that A, B, and C is larger than E, F, G, H by a factor of 2. All right, let's take a look at the practice set. A, all squares are similar. True or false? Well, if it's similar, it has to have identical angles, identical in number and size, but lengths of sides can be different. So are all rectangles equal? Well, all rectangles have 4 90-degree angles. Therefore, yes, they are similar. That would be true. B, all similar triangles are congruent. Okay. We already know they're similar. That means they have equal angles. However, congruent means that they have to have equal sides. Do all similar triangles have the same size of sides? And no, of course they don't. So therefore, that one's false, because sides in similar triangles can be of different lengths, as long as they have the same number of angles and the same size of angles. Look at C. If 2 polygons are similar, then their corresponding angles are equal in measure. True or false? Well, that's definitely true. Okay? Angles of corresponding angles in similar polygons are always equal. Okay? Always equal. That is always true. Letter D. These 2 triangles are congruent. Okay? First of all, congruent means angles are equal and the length of sides are equal. Which side of PQR is the same length as line segment AB? Okay? Now if you look there, AB seems to be the shortest side of the 3. So which is the shortest side of QRP? Well, line segment PQ is the longest side, we compare RQ and RP, I would say RQ is the shortest, so it would match up with the shortest on, which is AB. Moving on to E. Which two triangles appear to be similar? Similar means they have equal angles. Well, one is definitely smaller than two, but if we flipped it, if we did a reflection on it and flipped it over so it was pointing the other direction, it would have the same kind of angles or the same size of angles. Look at 2 and 3. They're the same height, but has nothing to do with similar. However, the angle at the top of number 3 definitely looks narrower or more pointy than the one at the top of 2. So definitely 2 and 3 are not similar. 1 and 2 are similar because they have the same size of angles, even though they don't have the same, their sides are not equal in length. Okay, question number 4. We have a pentagon. It has sides of 1 inch, 2 inch, 2 inch, 1 inch. And we don't know how long E is. Okay? So we got to figure that out first of all. 1, 2, 2, 1. And we know they're similar. And we know that this other one over here is 9. And that we're told that the scale factor is 3. Okay? The scale factor for corresponding sides is 3. So, if this one's 3 times bigger, then what is this? We have a scale factor of 3. So that means 3, take this 9, divide it by 3, and we get 3. So, that also means if I take this side and multiply it by that scale factor of 3, I've got 3 here. 3 times 2 is 6. 6, 3, 9. So now all we have to do, I think it asks for how long is IJ? Is 3. And how long is AE? We have 3. Okay? This is fairly simple if you think it through logically. If you have any questions, make sure that you ask me.